I'm going to be talking about CSS, JavaScript, and accessibility. Okay, great. So you may have heard this before, but HTML is by default accessible. So a lot of the work of web accessibility is more about just ensuring that that content remains accessible. So taking a bit of a step back, broadly speaking, we can define web accessibility as the inclusive practice of ensuring there are no barriers that prevent access to websites. So this is basically just about making your website as inclusive to as many different people as possible. But I think when it comes to accessibility, there's three groups of people that it makes sense to really think about because they have very specific access needs. So firstly, people with physical disabilities, and this is typically what we think about when it comes to accessibility or disabilities. So people who may have a long-term or permanent impairments like visual impairments or auditory or cognitive impairments. But then we also have situational disabilities. So this is looking at how, in practice, due to a particular situation a person is in, they may actually require similar access needs to someone who has a more long-term or permanent disability. So typical example is someone just holding maybe a baby in one hand and only having one hand available to use their computer, do whatever they're doing. So even though, in theory, they have, two working hands. In practice, they might require a similar access need to someone who only has one functioning arm. And accessibility also relates to how people with socioeconomic restrictions can have access to a website. So this is looking at how people who may be data conscious may be able to or not be able to access certain websites just due to the cost of opening up a web page that might be like really large and actually cost a lot. But yeah, like I said, accessibility is basically about inclusion as a whole. So by looking at these three groups of people, we just make a website that is more accessible to everyone, everywhere. So as you probably know, the bedrock of web accessibility are the Web Content Accessibility Guidelines. And they basically group the guidelines under four key principles. So first, that content must be perceivable. So this basically means that people should be able to perceive the content on a web page using one or more of their senses. So this is basically about making sure that if someone isn't able to visually read content, then it's written in a way that it can be maybe converted to audio, or they can use some other input device to actually still be able to access that content. Then secondly, user interface components, so things like buttons, forms, all of that, must be operable. So people should be able to use whatever input device they need in order to actually navigate and operate the web page. Then thirdly, the content must be understandable. So this is about making the content basically easy to understand, easy to read, and also making sure that things work in a way as like somebody would expect. So if they, click a link, it should take them to the place where that link says it's going to take them. And then finally, the code must be robust. So this means that web pages should be able to be interpreted by user agents, including assistive technologies like screen readers. So why do we say that HTML is by default accessible? So firstly, there's a little bit of a caveat in that it still needs to be used correctly. But at the end of the day, if we are creating a website that's basically only maybe 100% HTML, we end up with something that's usually very accessible. So if you had like a very basic website, obviously this is not what websites look like again today, but if we were to run an accessibility check on it, it pretty much always passes like 100% with flying colors, because I think just the plain old semantic HTML is basically like the pinnacle of accessibility. Which isn't to say that HTML cannot be inaccessible. We can still create web pages that are purely HTML that end up not being all that accessible. Like we can do things like not include text alternatives for non-text content like images, or we could just use completely the wrong elements for things. So you could use a span to label an input instead of an actual label element. Or if you wanted to actually do damage, you can use attributes like tab index to just completely mess everything up. But basically, HTML on its own is pretty much pretty good. It's kind of just like chilling there. And we only really get into issues when you add like CSS and JavaScript to the mix. It's kind of just coming out of nowhere and maybe really messes things up. Like we can use CSS to do stuff like just add content into the page with CSS. I don't know why people would do this, but you can see sometimes it happens. Or you can just completely alter the element behavior with JavaScript. But I think why a lot of the content around accessibility is focused on HTML is because basically 90% of the work of accessibility is just using HTML correctly. And the other 10% is about not using CSS and JavaScript incorrectly. So that's kind of what this talk is about, the other 10%. So how do we write our CSS and JavaScript in a way that doesn't hinder, but actually maybe improves accessibility? So firstly, CSS and accessibility. So it's always helpful to kind of take a step back to see like, okay, what is the purpose of CSS in the first place? And that is to, describe the presentation of an HTML document. So while HTML provides like the content of the document, your CSS is there to describe how it looks. And we see this with how, HTML and CSS comes together to create the render tree and eventually what is painted on the web page. So from our HTML, we get the DOM, the document object model, which basically just includes all the elements and any content within them. And then from our CSS, we have the CSS object model, which includes each element and any styles related to them. And then these two together form the render tree, which also does not include any non-visible elements, so like your head or any elements that have a style like display none on them. And yeah, like I said, these two together form what is going to be like actually visibly painted on the page. But this isn't necessarily what is used by user agents and assistive technologies. So for the most part, it's mainly like the HTML and the DOM that's actually used by assistive technologies. And it's actually from the DOM alone that we get the accessibility object model. And what that is essentially operable elements and any like things related to it. So you have stuff like the name, the label, like the states, things like that. And all of this is really important for a user of assistive technology because if you were visually trying to fill out this form, it's pretty easy to tell what is going on. You can tell like, oh, these two radio buttons are connected and one of them is selected, or you can tell like what is happening with the checkbox, whether it's selected or not, what the label is. But if you couldn't actually just visually look at this, the only way to get all that information is from the accessibility object model. And that's why it's really good that we have this separation of concerns between HTML and CSS. So it's really important that all that information, the content and things like the states of things is within the HTML. So that brings me to my first point, which is that we shouldn't be using CSS to convey any meaning or content. And the way we typically see this happen is maybe just using the content property. So like I showed a bit earlier, you could, in combination with the pseudo elements, actually just inject content onto a page. I don't know why anyone would choose to like put the header this way, but this is something you can technically do. And the support for CSS-generated content with browsers and screen readers is still sort of like not very consistent. Like I mentioned, CSS isn't part of the accessibility object model, but we do get some browsers and screen readers that try to support including that in whatever they are reading. But as you can see, it's not very consistent. And this is a great article that basically summarized the state of the support for CSS-generated content. And the summary of the article essentially said that even though some do, you basically just still shouldn't use CSS-generated content to alter or create any important content on the page. And I generally just suggest that when we're using the content property, it should basically just always be empty because adding any content is not going to be very reliable. So another way we can use CSS to, add new content or meaning to a web page is by basically using styles to convey particular meanings. So if you are filling out a form and you are trying to convey, okay, which input fields are successful, which have errors, you could technically use CSS for this to just change like a border color, but that's not something that would be accessible to users of assistive technology. Or another example is we can use CSS to determine, okay, which of these two prices is the correct price. If you were navigating this web page using anything but, your eyes, there's basically no way for you to determine which is the correct price. So my second point, so in addition to not using CSS to create or add any new meaning to the page, we also shouldn't be using CSS to change the semantics of HTML. So we see this a lot when you're trying to, fix using the wrong element for something. So, for example, you can want to add like specific emphasis into a particular string, and you could do that by using the actual emphasis element, or you could just use a span, which doesn't really mean anything on its own, and then use CSS to add that additional meaning. And to somebody who's just looking at the web page, both of these two things would look exactly the same, but to people who are using assistive technology, one has meaning and the other essentially doesn't have any meaning. But I would say another way in which we can use CSS to kind of change the meaning or the content on an HTML page is when it comes to trying to like hide things. So there are many different ways that we can result in an element being visually hidden on the page. So anything from using display none to visibility hidden, opacity, position absolute in combination with other things. And they will all result in that element being hidden visually on the page. But they all are very drastically different in how they impact things under the hood. So all the way from whether the box model is generated, whether it affects layouts, and then crucially, whether it's being read by assistive technologies. So I would say the most common thing that people use is display none, because it's pretty simple and it, of course, does visually hide things, but it essentially just removes it almost from the page entirely. An example here is if you wanted to create a tooltip element. So you can see something that's not visible unless you like hover over it. And you might be tempted to use display none to hide that tooltip until somebody actually hovers over it. But the issue here is that even though it is visually hidden, the element will no longer be able to be read by assistive technologies. So you might think, okay, the right property here to use is the visibility property because it's called visibility, so you might think that's all it's about. But unfortunately, it's not really about that, or it maybe doesn't work in a way that you might think it will work. So as an example here, you can see there's 3 elements, and you can see there is actually a middle element here, and it's still actually taking space on the page, even though you have this visibility hidden property on it. So it actually functions a bit more like an invisibility cloak than anything else, really. And I think as a slight tangent, I would say, or at least I've yet to see a good reason to use the visibility property in this way, because I think in a lot of cases where you want to just hide something visually, but it's still going to affect layout, it maybe makes more sense to just use the opacity property, because then in that case, at least it would be able to be read by assistive technologies as well. But I don't know, if anyone has successfully used the visibility property, I'm open to hearing what people think about that, but I don't know. I haven't really seen a good use case. But yeah, basically, I think the best way to have the best of both worlds, in that you want to hide something visually, but then also have it still be able to be read by assistive technologies, is to basically use position absolute in combination with a bunch of other properties in order to effectively just like hide it off of the page. So another way we can use CSS to really like change or alter the meaning of our HTML is to have a completely different source order from our visual order. So we can do something like this where in our actual HTML, we have ordered things in a way that doesn't really make sense. So we can have like the footer at the top, the header somewhere in the middle, everything basically not in essentially a logical order. But we can then use CSS Flexbox or CSS Grid in combination with other properties to essentially then, I guess, fix it. And this is actually highlights one of the things about new technologies like CSS Grid and Flexbox, in that they are really powerful tools, and they actually are almost like the pinnacle of CSS in being able to have that true separation of concerns between your HTML or your styling, your HTML and your CSS, so your styling and your content. But because we have that true separation of concerns, it then enables us to do things like this, which isn't necessarily a good thing. And that's why I really like how Rachel Andrew put it, in that with this great power of having access to this tool comes great responsibility, because it gives us the potential to do a lot of damage. So my third point is that we shouldn't write CSS that undoes the default accessible styles. So as we all know, every browser comes shipped with its own default browser CSS. And that is written in a way to be as accessible and applicable to, I guess, as wide array of websites as possible. So again, kind of like Jeremy, I always like to use the example of a button here, because I think we get so much from it. So just by using the default button element, we get, the text and element sizes are right, the colors and contrast is right, and we get styled, hover, focus, and active states. And that's sort of why I like to think of any custom CSS I write as like almost standing on the shoulders of the giants, in this case, I guess the browser CSS, in that it should always be done in a way that is additive to the experience and not sort of like undoing all the good work that has already been done before. So if I wanted to change the font size, I shouldn't make it too small. Or if I'm going to change the color, I shouldn't just change it in a way that's going to affect like the contrast and things like that. And even when looking at the states, like the different states of things like a button or other operable elements are really important. So having actually defined hover, active, and focus states is something that is still really important. And these styles in particular are particularly hard to deal with. They're not necessarily applied consistently across browsers, and particularly on touchscreen devices like hover, focus, and active are essentially all the same thing. So it's kind of hard to style them very distinctly. And then even working with them is really difficult. So if you, in your CSS, were to define your active styles first, then your focus styles, then your hover, basically the only style that would apply would be the hover. So you actually have to make sure in your CSS you order it the right way so that all the styles actually apply. Basically, they're kind of just a pain to work with. But they are still incredibly important. So if you didn't have these different states, people who are trying to navigate your website using like a keyboard, or basically just not by pointing and clicking, would have almost no way of knowing where on the page they are or what they're interacting with. So it is really important to have these distinct states. So that's why if you did want to make any changes here, you shouldn't just completely remove all the focus styles, for example. You kind of have to do them in a way that is, like I said, additive rather than just completely removing them. Or you can make use of new pseudo classes like focus visible, which will only allow you to style when focus should be visible. So basically, if somebody is using tabbing into an element instead of clicking on it. So I think the point here is that as much as possible, we should think about writing custom CSS cautiously. We shouldn't think of it as something that is not necessarily important or just kind of make changes in a haphazard way. We should kind of do it knowing that there is a good default that has already been established. So anything that we're writing or changing, we should do so cautiously. So, so far we've talked a lot about what we shouldn't be doing with CSS, but there is a lot that we can do to actually improve accessibility. So firstly, we can use custom CSS to improve on the default accessible styles. So like I mentioned, each browser ships with their own CSS, and it's built to be as accessible to as wide array of websites as possible. But that kind of means that the CSS isn't necessarily optimized for any particular website. So there are changes that you can make or additions that you can make that will actually improve on things. So a good example here is this guideline around visual presentation for text box. So it says if there's very like text-heavy sites, the text box shouldn't be wider than 80 characters. Line height should be 1.5 times text size. within paragraphs, 2.25 times the text size between paragraphs. And basically, the default browser CSS doesn't actually meet these requirements. And this is not necessarily a problem. Like, it's something that they are aware of, and it's something that it's like they're actively choosing not to change. And that's because, like I said, this guideline is for particular types of sites. So it is for a site that has, maybe it's like a news site or something that is particularly text heavy. And it doesn't make sense for the default CSS to be like geared towards that particular use case. So this is a great opportunity for, if you know like your particular website is that type of website, that's where you can add some custom CSS. So you can add just like a few lines of code that could essentially fix this problem for your particular website. Another example is this guideline around adding bypass blocks. So basically, this is a link at the top of your website. So I'm showing an example. So if you're in Wikipedia, for example, if you hit tab, the first thing you're going to see is the link to skip to the main content. And that essentially allows you to bypass through all the repeatable navigation and just go straight to the main content. And the way this is typically added is you add a link, the first thing in your body, and then in your CSS, you can hide it by default and then show it when it comes into focus. But this is an example of something that it doesn't make sense to just be included in every single website by default. And even in the guidelines, it says that it's not something that is necessarily needed for every particular website. It's something that you should think about whether it makes sense for your particular site and then include it. So another way we can write some custom CSS is to adapt to the different end user's device capabilities. And this is essentially about writing CSS with progressive enhancement in mind. And one of the simplest ways we can do this is with the CSS Cascade, which is essentially built-in progressive enhancement into CSS. So we can do things like take advantage of modern features like CSS variables while still supporting older browsers that don't necessarily like have this feature enabled. So the newer browsers will make use of the latest and greatest, but then for browsers that don't, they will fall back to the more legacy code. But we also have, nowadays, we also have feature queries, which essentially allow us to create a bit more complex interactions. So we can determine if the browser supports a particular property value pair and then have a bunch of CSS based on that. So a typical example here is if we wanted to have a legacy layout code, so we can have a layout based on display tables for extremely old browsers, because I don't know who uses tables at the moment. But then for browsers that do support display grid, we can then have a layout based on that and have a bunch of other code there. So finally, we can also use our CSS to adapt to user preferences. So this is also an idea that Jeremy covered, the concept of user style sheets. So back in the day, we used to have this concept where each end user could write their own CSS and upload it to their browser, and it would essentially be applied across all websites. So you could have something like, I don't know, make all websites look dark mode or have a particular like color scheme. And this idea didn't really take off. So I think back in 2013 or something, Chrome essentially removed this feature from their browser. But we still have this concept that end users should have as much control over the environment they use to access the web as possible. And as we saw earlier, this is now represented in things like the prefers media queries. So we can query specific preferences that a user has and then write CSS based on that. So next example, we can adapt to a user's preference for reduced motion. So we can say, instead of showing them the most like fancy animation, we can show them something that's maybe a bit stripped back. And then the user can set this basically in their system. So in their, this is an example of a Mac. So you can see how there's like an option for reduced motion. And there's basically a bunch of different options that you can have that websites can kind of like plug into and then maybe change their experience based on that. So like I said, motion preferences is just one of these examples. We can also adapt to a user's preference for reduced data or color preferences or contrast preferences or transparency preferences. And I'm sure there's like probably a ton more preferences that we can or we will be able to plug into in the future. But basically, this is just about giving users as much control over their experience as possible. So even though users no longer really have a way to, write their own custom style sheets, they should still be able to have as much control over their web experience as they can. So that's it for CSS and accessibility. So as we covered, we shouldn't really be using CSS to convey any meaning or content, since that's the job of HTML. And we shouldn't use CSS to, change the semantics of HTML that has already been set. And we shouldn't write CSS that undoes the default accessible styles. But on the other hand, we can use CSS to improve on these default accessible styles and make it more specific to our particular website. And we can adapt our CSS to the end user device capabilities and also user preferences. So next, JavaScript and accessibility. So like we did with CSS, it's always helpful to take a step back and look at what the purpose of JavaScript is, which is to make web pages more interactive. And I'll put an extra emphasis on the more here, because we tend to forget that HTML on its own is actually pretty interactive. Like, we have a bunch of elements that we can use to make a web page quite dynamic and interactive on its own without necessarily having to add JavaScript to the mix. So that's why I always like to think of JavaScript as like the icing on the cake. It's something that's nice to have, nice to add, but not necessarily a requirement, because you can still have a perfectly nice cake without having ice cream or icing on top of it. So that brings me to my first point, which is that we shouldn't use JavaScript for functionality that HTML already provides. So again, using the example of a button, just by using the button element, we get a lot for free. So it's able to be triggered by the mouse, enter key, and spacebar. It's able to be focusable via the keyboard and other input devices, and it has an accessible name and state provided to assistive technologies. And this is something that we get just by using the button element. But as we also saw with Jeremy's talk, we can try to recreate all of this using a div. And as we saw, it's a whole lot extra work. So we have to do a lot more just to get to that same experience. So we have to, make sure that the element is able to be tabbed into by adding the tab index attributes. We have to make sure it has a role that's being communicated to assistive technologies. We have to make sure that we are handling it being able to be triggered by both a mouse, a keyboard, enter key, and a space bar key as well. And if it's a toggle key, we need to then make sure that we have a pressed state being communicated to assistive technologies as well. And it's basically just a lot of extra work that we're doing to basically, mess ourselves up for some reason, because we can get all of this just by using the button element. And I think another way in which we see maybe the incorrect element being used is with links versus buttons. So instead of having just a regular link that goes to a particular page, you sometimes see it being a button, and then the navigation is completely abstracted into JavaScript, essentially. And I think a lot of the times the reason we see this is because people typically might want to do some other things in addition to the navigation. So you might think it makes sense to just completely abstract the whole experience into JavaScript instead of trying to manage two different things. But I think this kind of represents a mindset that isn't necessarily the best, right? So I always try to think that whenever we're trying to use JavaScript, we should keep any JavaScript enhancements as unobtrusive as possible. And what that means is essentially making it something that's additive rather than changing the default experience. So making sure that this is something that is actually an enhancement and not necessarily a change. So in this example, we could still have the best of both worlds. So we could still use a regular link that has an href attribute that works and will take the user to a particular page. But we can still, if JavaScript is available, still have the best of both worlds. So still being able to do the other things we want to do by first just preventing the defaults, doing the other things, and then still like controlling the navigation with JavaScript. And then if JavaScript is not available, then the default experience of the link taking you to the About page still works. And that's why I really like the using event.prevent defaults, because I think it sort of represents the mindset that there is a default experience in the first place that you can prevent and then add something extra if JavaScript is available. But if JavaScript is not available, the default will still prevail. So my next point requires a bit more nuance, which is that, where possible, we shouldn't require JavaScript for critical features. And the reason this requires a lot of nuance is because obviously nowadays, what we expect web pages to do does typically require JavaScript. Like most of the, powerful features that we have can't really be replicated without JavaScript. And I think Figma is a good example of this. You can't even really see what it looks like. But this is basically what the Figma website looks like without JavaScript enabled. So it's essentially a blank page. And I think Figma is a great example of a case where you do kind of require JavaScript for the main feature. I wouldn't necessarily expect them to have tried to recreate the entire Figma experience in a way that would work without JavaScript. And that's not necessarily to say that this particular experience couldn't be improved. Like they could still have some sort of maybe a no script tag that will explain why the page doesn't work without JavaScript. But I think, like I said, this is a good example of, well, sometimes you actually obviously do need JavaScript. But I think there are plenty cases where you can have a good experience without JavaScript. So this is Google search. If you didn't have JavaScript, you can see that you can still have access to the core feature of the website, which is being able to search for something and see those search results. But then if JavaScript is enabled, you get all these extra things. So like the autocomplete and like more richer results and I guess ads, which everybody wants, but you do get that. And there's also been a shift in terms of the web content accessibility guidelines, because when they were first introduced, they actually said that a website cannot be considered fully accessible if it doesn't support a feature where JavaScript is disabled. But nowadays, they have changed that and said that you are actually allowed to require JavaScript. And I think this sort of highlights a key difference between the different groups of people I mentioned earlier, because they actually have very different access needs. So people with physical disabilities are probably much more likely to rely on JavaScript. So only 0.07% of screen reader users have JavaScript disabled. And this is really a lot less than the global average, which is 1%. But if we look at people with socioeconomic restrictions, they are essentially the opposite. So they are much more likely to completely avoid JavaScript. So if you are looking at a place like Sudan, over 50% of mobile browsing is an Opera Mini. And in that browser, JavaScript is either severely limited or sometimes just completely removed. And JavaScript is usually a problem here because, compared to HTML and CSS, the average JavaScript file size is exponentially larger. So typically just by adding JavaScript to a website, you just make something that is much larger and much more expensive for people to actually consume. But I think it's about finding a balance, and it's really dependent on what type of website you're making and who your end users are, because maybe you're making a website only for, screen reader users who live in a place where they have the fastest internet and they're always going to have JavaScript enabled. So it makes more sense to invest more of your time and your energy into that JavaScript enabled experience. Or maybe you're making a website for people who only use Opera Mini on extreme mode. And in that case, there's almost no point in writing JavaScript because it's just not going to be seen by the vast majority of your end users. Or maybe you're making something like a Google or a government website where it needs to be accessible to basically everyone, everywhere. And in that case, you need to actually put almost equal attention to both of these experiences. But basically, the point here is that, adding JavaScript on a page on its own doesn't necessarily make a web page inaccessible. And in fact, JavaScript can actually be used to greatly improve the accessibility of a website. And that's what my next point is about, that we can actually use JavaScript to improve on the default accessible behavior. So this is an example. So guideline 3.3 is about helping users to avoid and correct mistakes. And by default, with HTML alone, we do kind of have this. So you can see that if I had added like a required attribute to this input field and I try to click submit, it will tell me, oh, I need to fill out this particular field. But the guidelines actually suggest going further than that if possible. So it says if an error is detected, you should also add suggestions for correction. And you can see how that's implemented if you're trying to create a Google account. So if you try to add a username that's already taken, it tells you it's taken in real time, but then it also even provides suggestions for what you can do instead. And that's something that you can't do if you didn't have JavaScript. So this is a great way to add JavaScript in a way that's like additive and actually improves on the default experience. Another thing to note is that some HTML elements aren't actually accessible enough yet. So I think the video element is a good example of this. It has a number of problems right now. So the controls aren't always like focusable via the keyboard, depending on what browser you're using. You can't always pause or play using the space key. And there isn't always, arrow key support for the scrubber and basically a lot more. So this is actually like a case in which even the W3 themselves recognize. So they say, modern browsers do have a default media player, but most of them actually very limited when it comes to accessibility. So this is actually a great place for you to use JavaScript to improve on the default accessible experience. So this is a great article that has a bunch of resources for HTML5 media players. So you don't necessarily need to build everything yourself. There's already quite a few good ones. Another example is with Canvas. So the content within the canvas isn't in the DOM, and therefore it's also not in the accessibility object model. We don't really have a proper way to add text alternatives for the content within the DOM, or within the canvas rather. And the elements within the canvas are also not like focusable via a keyboard or other like non-pointer devices, and again, so much more. But basically the point here is that sometimes we do actually need JavaScript to create something that is more accessible than the default experience that we can get with just using HTML alone. And my final point is when it comes to new components that don't already exist in HTML, this is another great example of how we can use JavaScript in an additive way. So as we know, the world of web development moves a whole lot quicker than browsers are able to implement new features. So there are many like UI components that are very commonly used in the world of web development that we don't necessarily see in browsers. So things like, drop-downs, carousels, tooltips, those are things that we sort of expect to be able to use, but we don't necessarily have the HTML element for it. And this is a great way, or this is a great example of where we can use JavaScript to create these components in a more accessible way. So using the example of a carousel, which is basically a list of elements, and you can see each item at a time, there's usually keys that will allow you to like navigate through, and then maybe like a pause and play button as well. And we can pull out a few of the guidelines from the Web Content Accessibility Guidelines that would be related to carousels. So firstly, this guideline, which is about that information and structure that's conveyed visually should also be able to be programmatically determined. And what this comes down to is essentially just using the right elements. So in this case, just using an unordered list essentially would fulfill this criteria. And then these next two are about making sure we have the appropriate controls, like to play, pause, and move between the slides, but then also making sure that they are keyboard accessible. So again, this just comes down to adding appropriate buttons. So we can add a button that will toggle the play and pause, and then also have buttons that will allow you to move between the previous and the next slides. And then finally, this guideline is around making sure that the names and roles of the various components should be programmatically determinable, which basically just means adding attributes that will label each particular part of the slideshow. So having like the label there, the description controls like what each button does and what each slide is. But basically, this example is just to illustrate that when we are writing these custom components, that we should do them cautiously, because there are many different considerations that we need to make sure that any component that we're creating isn't just accessible to one group of people, but not to all groups of people. So the W3 have this website, which just gives you a list of a bunch of different components that we use nowadays and the different accessibility considerations that go into creating them. So this is a really good resource. And we do also have third-party resources, like friend.co is a great collection of components that you can kind of take and use in your website. And I also think the Inclusive Components blog is really good because it gives you a real like deep dive into each of these components and different accessibility considerations for them. So that's it for JavaScript and accessibility. So basically what we covered, we shouldn't be using JavaScript for functionality that HTML already provides, because HTML is already pretty operable by itself and dynamic. And then wherever possible, again, depending on what type of website that you're creating, don't require JavaScript for critical features, or at least consider what the JavaScript disabled experience would be like. But we can use JavaScript to improve on the default accessible behavior, and particularly components that are not necessarily accessible enough yet. And we can also use JavaScript when it comes to creating new components that don't already exist in the browser. So the reason I always like to go back to this quote is because I think it represents a really nice or really good mind shift in how we think about accessibility, in that by default, HTML and web pages are already accessible, and web accessibility, or the work we do, is more about, like I said, ensuring that it remains accessible. So I really like this quote from George Kemp where he says, if someone tells you to make something accessible, you should instead tell them, but you don't intend to make it inaccessible in the first place, because that's really what accessibility is about. So thank you.